Here, this question says the two tangents make an angle of 70 degrees. We can see here, these two lines here are the tangent, because a tangent to a circle is any straight line that touches the circumference of the circle at a point from the outside. So that means this angle here is 70 degrees. Here, these blue line segments here are equal in length. Find the surface area of the shaded portion, which is this here, and the length of these blue colored lines. Here, provided that the circumference of the circle is 22 centimeters. So how can we solve this? From this triangle here, if we subtract the area of this segment here, we are going to be left with the area of the shaded portion here. So let's label this A and this B, and form an equation that area of A is equal to area of triangle, let's say triangle AB, minus area of B. So what is the area of B? B is the segment here, and the formula for finding the surface area of a segment is area of sector minus area of triangle. Area of sector is theta over 360 pi r squared, and area of triangle in a circle can be found using half r squared sine theta, because these two here are radii. Theta is the angle at the center, which is this angle here. So what is the size of this angle here? We don't know, but if you look at this here, it is having the shape of a kite, because this and this are radii, and here these two sides here are equal in length, because from the circle theory, if any two tangents are drawn to a circle from a point, the distance from that point to the point of contact is equal for both tangents. And we know the opposite angle of a kite must sum up to 180 degrees. So since this is 70 degrees, this must be 180 degrees minus 70 degrees, which is 110 degrees. So theta equal to 110 degrees. Substitute here and here now. Area of B equal to 110 over 360 pi r squared minus 1 over 2 r squared sine 110. Now what is r? R is the radius of the circle. We don't know its value. But from here, since the circumference of the circle is 22 centimeters, and we know that the formula for finding the circumference of a circle is 2 pi r, we can equate 2 pi r to 22 centimeters. So 2 pi r equal to 22 centimeters. Pi is 22 over 7. So 2 times 22 over 7 times r equal to 22 centimeters. 2 times 22 over 7 times r is 44 r over 7. To make r the subject, we multiply both sides by 7 and divide both sides by 44. Now we have 44 r over 7 times 7 divided by 44 equal to 22 centimeters times 7 all divided by 44. Here 7 cancels 7, and 44r divided by 44 is r. Here 22 centimeters times 7 is 154 centimeters. 154 centimeters divided by 44 is 3.5 centimeters. So r, which is radius, is 3.5 centimeters. Substituting here now, area of B equal to 110 degrees over 360 pi times 3.5 squared minus 1 over 2 times 3.5 squared times sine 110 degrees. If you press your calculator, 110 over 360 times pi times 3.5 squared is 11.7592, and 1 over 2 times 3.5 squared times sine 110 is 5.7556. So area of B equal to 11.7592 minus 5.7556, which is 6.0036. So area of B equal to 6.0036 centimeters squared. Substitute here now. Area of A equal to area of triangle AB minus 6.0036 centimeters squared. So what is area of triangle AB? We don't know. To find the area of triangle AB, we at least need to know the length of its sides, and for that we need the sizes of its angle. So what are the length of its sides? Recall earlier we proved that this side here is equal to this side because they are both tangent drawn from the same point. So let's label them P each. So since these two sides here are equal, the triangle here is an isosceles triangle, with this angle here as the vertex angle, and this are the base angles. And we know that the base angles of an isosceles triangle are equal in sizes each. So that means this angle here and this angle here are equal in size. So since this is 70 degree, this and this must be 180 degree minus 70 degree over 2 each, because the sum of angles in a triangle is 180 degree. Here, 180 degree minus 70 degree over 2 is 55 degree. So now what are the lengths of its size? We don't know. But if you look here, this side here is also a chord of this circle here. And we know that the formula for finding the length of a chord of a circle is 2r sine theta over 2. Theta is this angle here at the center, and we know that r is 3.5 centimeters. So length of chord B now equal to 2 times 3.5 times sine 110 over 2. 110 over 2 is 55 degree. 2 times 3.5 is 7. So length of chord B is 7 times sine 55. 7 times sine 55 is 5.7341, approximately equal to 5.73. So length of B equal to 5.73 centimeters. Substitute here now. To find the length of this side here, we can use the sine rule. So using the sine rule, 5.73 over sine 70 degree equal to P over sine 55 degree. Making P the subject, P equal to 5.73 over sine 70 degree times sine 55 degree, which if you press your calculator equal to 4.995, approximately equal to 5. So P equal to 5 centimeters. Substituting here now, since we have the length of all the sides of the triangle, we can use the Heron's formula to find its area. By Heron, if the length of the side of a triangle are represented by A, B, and C, the surface area of the triangle must be square root of S times S minus A times S minus B times S minus C, where S equal to A plus B plus C over 2. So if we let this to be A, this here B, and this C, A equal to 5.73, B equal to 5, and C equal to 5. Substituting here now, S equal to 5.73 plus 5 all divided by 2, which is 7.865. Now substituting all these values here now, area of triangle AB equal to square root of 7.865 times 7.865 minus 5.73 times 7.865 minus 5 times 7.865 minus 5, which if you press your calculator equal to 11.7401. So area of triangle AB equal to 11.7401 centimeters squared. Now if you come back here and substitute, area of A equal to 11.7401 centimeters squared minus 6.0036 centimeters squared, which is 5.7365 centimeters squared. So we found the area of A to be 5.7365 centimeters squared, which is the area of the shaded portion we are asked to find its area.